to my channel Math with Nazia. In this video we are going to learn about quadratic polynomial. I have already explained about quadratic polynomials in my previous video. You can refer that. The link is given in the description below. So let's see the first example for today, which is find the quadratic polynomial, sum of whose zeros is 8 and their product is 12. Find the zeros of the polynomial. So this question was asked in 2019 paper. So this is a very important question and a very easy question. So here in this question we know what is the sum of the zeros and we know the product of the zeros. So the sum of the zeros is 8 and the product of the zeros is 12. So we know the sum and the product. So now let's form the standard form of the quadratic equation. I hope you all remember the standard form of the quadratic equation, which is x square minus sum of the zeros x plus the product of the zeros, which will be equal to 0. So this is the standard form. Now let's apply. So it is x square minus 8x plus 12 equal to 0. So now we have this equation. Now we have to solve this equation to find the zeros of the polynomial. So x square minus 8x plus 12, we have to split 12. It should be minus 8 and 12. When you add, it should be add or subtract, it should be 8, and when you multiply them, it should be 12. So when do you get 12? Either 3 times 4, but 3 and 4 will not give us 8, so we can take it as 6 and 2. So we want plus 12 and minus 8. So I will take it as minus 6 and minus 2. So this can be written as x square minus 6x minus 2x plus 12. So we will take these, in these two we'll take x is common, we'll have x minus 6, and in these two we have minus 2 common, we'll get x minus 6. So here the answer we have got is x minus 6 is common, and here it is x minus 2. So we have to put that this equation is equal to 0. So therefore x minus 6 is equal to 0, x equals 6. We have one value of the zeros. Then if x minus 2 equal to 0, we have x is equal to 2. We have our another value. So this 2 is the zeros of the polynomial, zeros of this polynomial. Isn't it easy? First we have to write it in the standard form, then factorize it, and then find the value of x. So now let's see the second example for today. So now this is a second example for today, which is if x plus a is a factor of 2x square plus 2ax plus 5 plus 10, then find the value of a. So we have to find the value of a, and x plus a is a factor of this equation. So let's write the given equation as f of x equals 2x square plus 2ax plus 5x plus 10. So this is given to us, and one more thing which is given to us is this is a factor. So we can keep it as g of x equals x plus a, and since this is a factor, x plus a equals 0, so x is equal to negative a. So we have found the value of x. Now we have to substitute this in f of x. So f of negative a, in place of x we are going to write negative a. So 2 negative a the whole square plus 2a, and inside the bracket again negative a, plus 5 times negative a plus 10. Now let's simplify this. We get it as negative a the whole square will become a square. So this is 2a square. This will become minus 2a square minus 5a plus 10. So these two would be crossed out. This 2 will become 0. So we have minus 5a plus 10. Now we have to find the value. So we know f of a is equal to 0. So 5a, negative 5a plus 10 equal to 0. So we can write it as negative 5a equals negative 10. So both the sides that are negative we can cross it out. So a equals 10 by 5. So a equal to 2. So now we have got the value of a. So that was our question. Find the value of a. So the value of a is 2. Isn't it easy? So first we'll write f of x, then we'll write the g of x. We found the value of x. So this x, we will substitute the value of x, which is minus a, we will substitute in place of x and then find the value of a. Isn't it easy? So the standard form of the quadratic equation is x square pause. So the standard form of the quadratic equation is x square minus the sum of the roots, that is alpha plus beta x plus the product of the roots, that is alpha beta, equal to 0. So this is the standard form of the quadratic equation. You can also write x square minus sum of the zeros x plus product of the zeros. Whichever you remember, you can use that. Both are same. So here it would be x square minus of minus 7 by 3 x plus minus 2 equals to 0. So we have this now. Let's further simplify this as x square plus 7 by 3 x minus 2. So we have got this equation, which is x square plus 7 by 3x minus 2. So now since the equation is in fraction, I'm going to remove the denominator. So I'm just going to multiply this whole equation with 3. So if I'm going to multiply the whole equation with 3, I would get it as 3x square plus 7x minus 6. So as you could compare with the equation given, what is given to us is ax square plus 7x plus b. As you could see, 7x is same, ax square, which is in place of a we have 3. So a can be written as 3. We have got the value of a, and in place of b it is minus 6. The value of b is minus 6 or negative 6. So we have found the values. That was our question. Find the value of a and b. So the value of a is 3 and the value of b is negative 6. Isn't it easy? And this is a very important question, and this was asked in 2011 question paper. So first we'll got the zeros of the quadratic equation. We will find the sum of the zeros and the product of the zeros, form it into a standard quadratic equation, and then find the values of a and b. Now let's see the fourth example for today, which is if alpha and beta are the zeros of the polynomial p of x equals 2x square plus 5x plus k, satisfying the relation alpha square plus beta square plus alpha beta equals 21 by 4, then find the value of k. So this is a fourth example, and this is very important example. This was asked in 2017 question paper. So all these are very important questions. This may be asked in the board exams. So now let's see what is given to us. What is given is the polynomial is given p of x. So let's write what is given. P of x equals 2x square plus 5x plus k. So this is given to us. So here, as you could see, a equals 2, b equals 5 and c equals k. I think you remember the quadratic equation which we have learned it is in the form of ax square plus bx plus c equals 0. So that's the reason I have taken the value of a is 2, b is 5 and c is k. So now since the alpha and beta are the zeros of the polynomial, let's find what is alpha plus beta, that is the sum of the zeros. So alpha plus beta, we have the formula as minus b by a. So minus b by a, so what do we have in b? We have 5, so minus 5 by 2. So that is the sum of the zeros, that is alpha plus beta. We have got what is alpha plus beta is minus 5 by 2. Now let's find what is the product of the roots, which is alpha times beta. We know the formula, which is c by a. So we have got c as k, k by 2. So alpha times beta is k by 2. We have got the values. Now let's substitute in the given relation. We have got as alpha square plus beta square plus alpha beta equals 21 by 4. So let's start substituting in that equation. So let me write the equation first. X alpha square plus beta square plus alpha beta equals 21 by 4. So this is what is given to us. So we don't know what is alpha square beta square, but we know what is alpha beta. So we have to simplify this. So this can be written as alpha plus beta the whole square minus alpha beta. I think you would be confused that how did I get this. So let me explain you. We have a formula as a plus b whole square, which is equal to a square plus b square plus 2ab. So as you could see here, we have alpha square, we have beta square, and we have one ab. That's one more ab remaining. So I could separate this 2ab as a square plus b square plus ab and another ab. So this side will remain the same, a plus b the whole square. Now one ab I am going to bring it to the other side. So this will become a plus b the whole square minus ab equals a square plus b square plus ab. So a square plus b square plus ab, we have a formula we have derived from this a plus b whole square formula. So we have got it as a plus b whole square minus ab. So I have written that here equals 21 by 4. So this is just the formula which we have derived. So alpha plus beta the whole square. So we know what is alpha plus beta, that is minus 5 by 2 the whole square minus k by 2 equals 21 by 4. Now let us further simplify this. So this minus 5 by 2 will become 25. Now let's further simplify this. Minus 5 by 2 the whole square will become 25 by 4 minus k by 2 equals 21 by 4. Now I'll bring this 25 by 4 to the other side. So k by 2 equals negative k by 2 equals 21 by 4 minus 25 by 4. So this left hand side will remain the same. So 21 minus 25, which is minus 4 by 4. This can be crossed out. This becomes 1. So minus k equals minus 1. Minus k by 2 equals minus 1. So this minus and minus would be crossed out. And let's cross multiply this. So k equals 2. So we have found the value of k. So it's very simple. The question looks very tricky, but when you divide it into parts and understand and simplify, this is very easy. First, the p of x, whichever is given, we will find the values of a and b. Then we will find the sum of the roots. Then apply it in the relation which is given, and then find the value of k. So if you have any queries regarding these type of questions, you can comment down in the comment section. And for more tips and tricks, do like and subscribe to my channel. Thank you.